Welcome to today's webinar. The topic today is Masonry design using finite element analysis in RFEM 6. My name is Andreas Hörold. I'm responsible for marketing and PR in the Dlubal Software company. For instance, the Dlubal website, the German and English webinars, newsletters, and so on. I will be the moderator today, and I will answer your questions together with Frank Faustich. Ulrich Lex will be the presenter, but my both colleagues can introduce themselves.
Yeah, hello to all. My name is Ulrich Lex. I'm responsible for the global program RFEM and the add-ons Masonry and Glassbau in the company. And I will be the presenter of today's webinar.
Hello, my name is Frank Faustich. I'm responsible for quality management in Dlubal company, and today I will answer your questions.
Okay, thank you. Then we can switch off our webcams that the attendees can see the full screen. For all who participate such a webinar the first time, you can show or hide a control panel with that arrow here and then enter a short question here. And Frank and me will answer you. If you don't get an answer during the webinar, because there are too many, you will get an email with your answer after the webinar. The other way is to watch the entire webinar and then email your questions to info@dlubal.com. Okay, then I hand over the screen to Ulrich Lex. Just a moment.
So, hello again. Today I will show you how you can create a model with Masonry and design it in an RFEM program. I will take a look on some details of Masonry structures and at the end on the result evaluation and documentation. So I will start directly with the program. I have prepared a structure with lines and nodes so that it is easier to continue. You can import this such a structure also via DXF, or if it's possible with a Revit, if you get this file. So at the beginning, when you work with the Masonry add-on, please check in the base data if the module is checked on. This is necessary that the material model is available in the program. If it is checked on, you can continue with OK. So for the first step, I want to create some new materials. So I can do it here with new material. I can choose one new. At first, I can choose the material type Masonry, and here's the material model what I want. Basically, we have two different material models for Masonry. The one's isotropic one, some of you know it maybe from RFEM 5, and the orthotropic Masonry, where you consider the stiffness in both directions and the shear stiffness of Masonry exactly. So this orthotropic one is the best one. Now you can choose a material from the library. I want to create a new material for the outer wall, maybe in Porotherm. In the database, there are still only products from Austria, but we are continuing to develop or implement some new material as far as we can. So if you read in the materials, you can see in the standard classification, the table is filled out. You can this do also with some data sheets from a manufacturer. You get all values, I think, from the manufacturer. One value, maybe not. It's the horizontal compressive strength. Maybe you can ask the manufacturer, or you can use some default values. This value this value comes is depending on the group, and here you can say maybe for the group 1 you can use 80%, for group 1 60% from the compressive strength, for the group 1S 80%, from the group 2 10%, for the group 3 5%, and for the masonry group 4 100% of the compressive strength FB. Set the default values if you have nothing better from the manufacturer. Okay, then I will continue and create the next material for the inner wall. It's the same like before. Okay, I have to do it again to create a new one. And the third one, I want to create a patio and use a full stone maybe. And as the last material, I want to create a concrete for the slabs. So very important, you have to set always the orthotropic material model. Okay, the next step I want to do is to create the thickness. So the first thickness will be the outer wall with 380 millimeters. The second one with 170 millimeters. The third one 250 millimeters. And as the last, the concrete one with 200 millimeters. So now I have defined the material and its thickness. Then I can start to create the surfaces. As I have already the nodes and lines, I can do it with select boundary. I can choose my thickness for the outer lines or for the outer wall and choose my lines. To create the wall. I will do it for all walls. This one. And upstairs, I have also 4 walls. And the last one. Okay, as next step, I want to create the inner wall. Choose my thickness. The material is automatically attached to the thickness. I only have one wall inside the building. As the third one, I want then add okay. I have here to choose this line. And as the last step, I want to create the concrete slabs. One for the roof slab. And the base plate. So, okay, that was the final thing. On the roof, or for the roof flat, we have the first thing what we have to consider if we work with masonry walls. If you have a masonry wall and a roof slab, then always the slab wants to turn up in the edges. That would cause a damage here in the masonry. That's why we have to create something that the slab cannot turn up. In this case, I want to create an attica in concrete. That this turn up cannot be happen. That's why I create here some additional surfaces in concrete. That's the attica. Oh, that's what's wrong line. Okay. Here on the patio, we do not want such an attica. That's why we have to think about another possibility to avoid this turn up. Here I decided to create a new member that I connect the slab in the first floor with the base plate, and to I would say hold the slab that it cannot be turned off. That's what. So here I can select it and double click and assign a new member, like a member type beam, create a new section, material concrete, dimensions maybe 250 to 250 millimeters. Okay. Now we have modeled the whole structure of the building. What have we think about it now? Important thing is also the local axis of the surfaces. For masonry, masonry does have a different stiffness in Y and X direction. That means the Y direction should always be in the direction where it is loaded, and the X direction is the other direction. The Z direction is important for in our program to evaluate the results. And I'm used to do or to orientate the local Z-axis in the same direction. I always use it in this way that I try that all local Z-axis shows inside the building. That's why I changed it for this surface. Here it's okay, here it's okay. So, and maybe this is inside, this is, we have to change. Okay, so far so good. The next step we can do is create the openings. The lines are still there. That's why we can use it. We can define it graphically. Here, here, and here. And here is the door. Inside is a door. Here we want to create such an arch. Okay. If we create openings in the material in a masonry surface, we have to think about the lintel. Because the masonry does not have a stiffness for tension. So it could be that this area fall out from the wall. In practice, there will be some masonry lintel or something else. But this is the reason why we have to create it in the program too. Therefore, I want to create a new member or assign a new member. Create a new section. Concrete, maybe with a width from 300 and maybe 50 millimeter high. Okay. If there are bigger openings, then it is the same. You have to create a lintel too, but we have to extend the line a little bit into the masonry wall. That's why I extend this line 10 or 100 millimeters. Into the masonry wall. The reason for this is that I can smooth the loads, that not one FE node gets the whole load from this lintel. To copy it. And I want to copy it also for the second opening. And here I can create, or I can assign this member to. So as a next step, I want to take a look on this arch. Here I do not want to assign any concrete lintel. I will assign a new surface with material, with masonry material. And the second one too. And now, is it necessary that the global y-axis is changed? Because my load transferring is parallel to this line, and therefore we have to change this global y-axis. I can do this in the surface dialog with specific axis, input axis parallel to a line, choose the y direction, and choose the line. It's the same for the second. Okay. So far, so good. The next step, what I want to take a look at it, is the connection between the masonry material and the concrete material. In the practice, I do not know if it's 100% connected. I would say maybe there's a little bit friction in the connection, but on the safe side, I would say I would assign a hinge where I disconnect these both materials. That's why I create a new hinge. In X direction, so that I have no shear connection between the masonry surface and the concrete surface. I will assign this to this surface, to the second surface, and also on the member behind. Okay. Okay, here can I check where the hinge is located. The same thing. What I have a think about it is for the inner walls. In practice, I think the outer wall is built up, and on a later time, the inner wall is built. Maybe there is some masonry connectors where this assigned, but I do not think that there's a full shear connection between the inner and the outer wall. That's the reason why I assign also a hinge in the local X direction. Okay. As a last step, we had to think about the connection between the concrete slabs and the masonry wall. Here it's a special thing for the masonry because the concrete slabs are lying not with the whole width on the masonry structure. And that's why we have to assign here a special hinge. It's called wall slab connection. I have to assign this on the slab. That's why I define it on the slab. I assign a new hinge, create a new one, and here I have the option to choose the slab wall connection. It's only a placeholder where I define the geometry of this connection. You can use the tab slab wall connection. I define here 100 millimeters and can assign it to the line and surfaces. I have to assign it here on the slab roof. Here on these lines. Here I have an opening, maybe for the stairway. Here I have not to assign this wall slab connection. Why not? Because the both walls are standing directly above and there is no slab connected. It could be possible that we have to assign it also for the base plate. Maybe when some insulating is assigned under before the base plate. But I will not do it for this example. So if you have assigned it to the surface and lines, really important, we have to generate the line hinges for the connected walls. You can do it with this button. One error we get, this is okay because our Attica is a concrete material and there will no hinge will be generated. Now you can see the generated line hinges. The amount of the hinges is not important because it's connected to the orientation of the surfaces and its lines. So this does the program automatically. If you continue with OK, you can see the generated line hinges. What happens? What happens here on this detail? I have prepared an extra file where I can explain it. What happens on the wall slab connection? The slab lies not above the whole width on the masonry wall. Now on the wall is some normal force. So the normal force does not have the whole width, so it is concentrated on a smaller area. Because of the deformation and the bending moment on the slab, this smaller area will be concentrated to this really small area in the wall above. In the wall on the wall under the slab, it's nearly the same. here I have on this place a concentrated area where I have this normal force. So this bending moment is depending on the normal force from the wall. So and our slab wall hinge does only this thing. That's only this, that we have a limit of the normal force and a limit on the bending moment. I can show this on the original file. If I open such a generated hinge, then we can see if we have no normal force, we cannot have a bending moment. If we have a normal force, we can have a bending moment too. So if the normal force is too high, that the stiffness or the compressive strength is overloaded, then we can have only a smaller moment again. And if you have too much normal force, then we cannot, then the detail point is overloaded and we have no stiffness on it. And that's why it is so important that we assign this hinge in case of a concrete slab. Okay. If we have assigned all these things, then we are ready with the modeling. I can continue with the loading. In our case, I want only a self-weight with 2 kilonewton per square meter assign. And for imposed load, also 2 kilonewton. And maybe 4 kilonewtons on this patio. Okay. So that's, this loading is only an example. So what have we checked before the calculation? We have to check the FE mesh. It's very important because of the nonlinear materials that we have, and that we have a good FE mesh. We can recommend that the FE mesh size should be between 200 and 250 millimeters. Of course, it can be that it have to be a little bit smaller or bigger, but it should be about this size. So also, is it necessary that you check it, you as engineer check it, and you can say as engineer that it is, I would say, a nice FE mesh. Because when you have too much small elements or too much triangles, then it could be that the calculation time is very high, that the calculation comes not to an end because of this inconsistent FE mesh. So it's necessary in some areas maybe that you then assign some mesh refinements or something else. So the next, what we have to check is the calculation type. For the calculation type, do we have 3 options? The first one's a geometrically linear, the second order, and the large deformation. I would recommend maybe the geometrical linear or the large deformation. The second order is as default the Picard solver. This solver is not so good for the masonry material model. For normal buildings, I would recommend the geometrically linear. It's also possible for the non-linear material model. And for structures where you have really thin walls, thin and high walls, I would recommend the large deformation analyze, because then you have the moments from the deformations in the system too. For the nonlinear calculation, is it always good to increase the number of load increments? I would recommend here a value of 3 till 5. It's because then the FE element will not be loaded on the first step with a complete load. If you want to see the results of each element, you can check it here, but it will be increase the file size. So you have to think about it. So that was all we have to consider, and now we can start the calculation. Oh, I forgot the support of the system. I want to support the base plate. That's why I assign here some spring constant, and now we can compute it. So here you can see the iteration process. You can see the load increments, what are computed. You get information about the FE elements. If you want to see this curve afterwards, you can check it in the calculation diagrams. Oh, and now the calculation is finished. When the calculation runs without problems, then all criteria for the masonry material are okay. For the masonry material, there is no check about the ratio. It's not possible. It is not possible because of the nonlinear behavior. Here now we can check the results. Maybe we can check the stresses, the stress in sigma y direction. And if I take a look on the walls, the masonry walls, then I can see that I have a maximum sigma y direction in tension from 0.048, and it's the same as we have here for the orthotropic details. We have a tensile ultimate tensile strength from 0.05. Here we can see that the computing of the material model is correct. That does not mean that we are overloaded or something else. We see that we only see that some elements have a tensile strength, but we have not more as that is possible for the material model. So okay. So the next detail what I want to show you is this arch. The calculation, the FE elements of this arch are now orientated in direction of this line. Oh, sorry. I have only to. You can see the local Y direction is in direction of the line, and that's why we can create this arch. I tried to compute this arch also by hand, I would say. I created therefore a separate model. When I take a look on a formula for such an arch, I get a maximum horizontal load for this arch from about 200 kilonewtons, with a loading of 77.5 kilonewtons. If I compute this in our program, I did a stability analyze where I compute the maximum load of this arch and get an increasing factor of 3.1. Then I have this 77.5 kilonewtons loading. And the normal force in this arch are about this 200 kilonewtons. That shows me that the analytical formula gives the same results as our material model from Masonry. Here I can take a look on the deformation, and it is like I would expect it as an engineer. The same is for an loading on a half side loading. So the deformation is looking like expected. Okay, then back to our thinker. Okay, now documentation and results. For the documentation, we can create a new printout report. If you create a new one, you can select a lot of tables, result tables, everything you want to document the important things you need. More important in my eyes is to document some pictures. This can be done also easily. Maybe that you choose the outer walls. Then can you see as we have it the maximum Y stresses here. You can see that the maximum compressive Y stresses on the minus side. This is the outside of the building. are on 0.79. And if I take a look on the material, the maximum compress strength is 1.9. So the design ratio is not 100% with this case. Okay, I can print this to the printout report via this printer button, print graphics to printout report. Here you can set maybe also a scale where you want it to print, or on the full page, and with save and show is it printed to the report. Exactly. So the next possibility I want to show you are the sections. You can create a new section. Maybe here. Okay, then you get results. You get results on this line, I would say. You can check the moments what are on the node, and all other results. Maybe the my, then I get the moment what is existing on this slab wall connection. Also, a possibility is to check this results with an result beam. Here I can assign a new beam, a new member, and choose a result beam. Then I can say, okay, I want to see my results, or to sum up my results in an area of 1 meter, and want to see it only on this surface. Here I have to create like a dummy section. But I do not want to design this section. I only want to see the results. And now I can see these results on as member results. Maybe also the moment. I can do the same for the line above. Result beam. Okay, and maybe also for the slab. Then I can see the results per meter on these different surfaces. This is a good way to check some special results. Okay, then now I'm on the end of my presentation. I would say thank you for listening, and hopefully you have seen something new about our program. And I want to give back to Andreas.
Okay, thank you, Ulrich, for this nice presentation. At the end of the webinar, I would like to show you where you can find the provided model and the recording. We record all our webinars, as the most of you already know. I hand over or take over the screen. So on our website, dlubal.com, you can find under news and events our webinars. Those are the next webinars about concrete design and most frequently asked questions. And this is today's webinar. If you click on it, you will find the recording in the middle here in the next days. But you will get an email with a link to that page here, and also with your attendee certificate. And then you find the presentation slides here and the provided model here. You only have to wait for the recording. Okay, if you don't have already RFEM 6, you can download our free full trial version. For example, RFEM 6 with all add-ons, also with the Maçonnerie design add-on, and you can use it for 90 days. If you have questions to our program or to the add-on, you can contact our sales team. For example, under support and learning, contact our sales team. You have to fill out the form, and our sales team will contact you, and you can ask them questions about add-ons and programs. Okay, then that should be all for today's webinar. I thank you for your attention. Thanks to Ulrich Lex for the nice presentation. Thanks to Frank Faustich for his help by answering the questions. I wish all a nice rest of the day, and bye-bye.